Arc flash calculations are not typically performed by engineers on every new building design. The requirement for these calculations is usually reserved for electrical systems that present a significant risk of arc flash incidents. These higher risk systems are defined as those operating at voltages of 1000 volts or greater, or those capable of producing currents of 1000 amps or greater. Consequently, the application of arc flash calculations is limited to a relatively small fraction of new building projects. Arc flash is a dangerous electrical explosion that can occur when a flashover of electric current leaves its intended path and travels through the air from one conductor to another or to ground. This can happen in any electrical equipment, but it is more likely to occur in high voltage or high current systems. The dangers of arc flash include severe burns, blindness, hearing loss, and even death. The heat from an arc flash can reach temperatures of 35,000 degrees Fahrenheit, which is 4 times hotter than the surface of the sun. The pressure wave from an arc flash can also throw people and objects across the room. Because of these dangers, it is important to take steps to protect workers from arc flash hazards. Arc flash calculations are used to determine the potential arc flash hazard at a particular piece of equipment. These calculations take into account the voltage, current, and clearing time of the electrical system. The results of the arc flash calculations are then used to determine the appropriate personal protective equipment, also known as PPE, that workers must wear when working on or near the equipment. Firstly, the voltage of the system is a critical factor. Higher voltage systems generally pose a greater arc flash risk. Secondly, the available fault current of the equipment is also crucial. Higher fault currents lead to more severe arc flash events. Thirdly, the clearing time of the overcurrent protective device, such as a circuit breaker or fuse, is important. Faster clearing times reduce the duration of the arc flash and, therefore, the hazard. There are several methods for performing arc flash calculations. One common method is to use a commercially available software program. These programs use complex algorithms to calculate the arc flash hazard based on the input parameters. Another method is to use a spreadsheet program and perform the calculations manually, using standard equations and formulas. This method requires a good understanding of electrical engineering principles and arc flash calculation methods. Regardless of the method used, it is important to ensure that the calculations are performed accurately and that the results are properly interpreted. The results of arc flash calculations are typically expressed in terms of incident energy, which is the amount of energy that a worker would be exposed to in the event of an arc flash. Incident energy is measured in calories per square centimeter. The higher the incident energy, the greater the risk of injury. Based on the incident energy, the appropriate PPE can be selected. PPE includes items such as arc-rated clothing, face shields, gloves, and footwear. The selection of PPE should be based on the specific hazards present at the job site. In addition to PPE, other safety measures can be taken to protect workers from arc flash hazards. These measures include energizing equipment before working on it using insulated tools, and maintaining a safe working distance from energized equipment. It is also important to train workers on the hazards of arc flash and the proper safety procedures. The National Fire Protection Association, also known as NFPA 70 standard, provides guidance on electrical safety in the workplace, including requirements for arc flash hazard assessments and PPE. The Occupational Safety and Health Administration, also known as OSHA, also has regulations regarding electrical safety. It is important for employers to comply with these regulations to protect their workers from arc flash hazard. Here are some additional details on the factors that influence arc flash calculations. The type of equipment is important. Different types of equipment, such as switchgear, panel boards, and motor control centers, have different arc flash characteristics. The configuration of the electrical system is also a factor. The length and size of the conductors, the type of grounding system, and the presence of any protective devices can all affect the arc flash hazard. The working distance is the distance between the worker's face and the potential arc flash source. The greater the working distance, the lower the incident energy. Arc flash calculations are an important tool for protecting workers from electrical hazards. By understanding the factors that influence arc flash and by taking appropriate safety measures, employers can help to prevent arc flash injuries and fatalities. Arc flash calculation software typically automates the process of performing these complex calculations. This software uses a database of equipment characteristics and system parameters to calculate the incident energy of various locations in the electrical system. Some software programs also include features for selecting PPE and generating arc flash warning labels. Arc flash studies are typically conducted by qualified electrical engineers or technicians who have specialized training in arc flash hazard assessment. These studies involve collecting data on the electrical system, performing arc flash calculations, and developing recommendations for mitigating arc flash hazards. The data collection process typically involves reviewing electrical drawings, inspecting equipment, and measuring voltage and current levels. The recommendations for mitigating arc flash hazards may include upgrading protective devices, installing arc flash barriers, or implementing administrative controls such as lockout-tagout procedures. Arc flash training is essential for workers who may be exposed to arc flash hazards. The training should cover the hazards of arc flash, the proper use of PPE, and the procedures for working safely on or near energized equipment. The training should also cover the requirements of NFPA 70E inertia regulations. Lockout-tagout procedures are used to de-energize equipment before working on it. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being accidentally energized. Lockout-tagout procedures are an important part of arc flash safety. Arc flash barriers are physical barriers that are used to protect workers from arc flash hazards. These barriers can be made of metal, plastic, or other materials. Arc flash barriers are typically used to protect workers who are working on or near energized equipment. Incident energy reduction methods can be used to reduce the amount of energy that a worker would be exposed to in the event of an arc flash. These methods include using current-limiting fuses, arc flash relays, and other technologies. Current-limiting fuses are designed to quickly interrupt high-fault currents, which reduces the duration of the arc flash. Arc flash relays are designed to detect arc flash events and trip the circuit breaker to quickly de-energize the equipment. Here's a more detailed breakdown of the typical arc flash study process. The first step is data collection. This involves gathering all the necessary information about the electrical system, including single-line diagrams, equipment specifications, protective device settings, and conductor information. The engineer will typically review existing documentation and conduct a site survey to verify the accuracy of the information. The next step is to create a model of the electrical system in the arc flash calculation software. This model will represent the electrical network, including all the components and their interconnections. Accurate modeling is crucial for obtaining reliable results. After the model is created, the engineer will perform the arc flash calculations. This involves simulating various fault scenarios and calculating the incident energy at different locations in the system. The calculations are typically performed at multiple locations to identify the areas with the highest arc flash hazards. The results of the arc flash calculations are then used to determine the arc flash boundary and the required PPE for each location. The arc flash boundary is the distance from the potential arc source within which a person could receive a second-degree burn in the event of an arc flash. The PPE requirements are based on the calculated incident energy level. The final step is to prepare a report that summarizes the findings of the arc flash study. The report will typically include a description of the electrical system, a summary of the arc flash calculations, recommendations for mitigating arc flash hazards, and arc flash warning labels for each location. The report should be clear, concise, and easy to understand. The periodic review of arc flash studies is necessary because electrical systems can change over time. Changes such as the addition of new equipment, modifications to protective device settings, or changes in the electrical system configuration can affect the arc flash hazard. Therefore, it is important to review and update the arc flash study periodically to ensure that it remains accurate and up to date. The frequency of the review should be based on the specific circumstances of the electrical system, but a good rule of thumb is to review the study every 3 to 5 years or whenever significant changes are made to the electrical system. The specific requirements for arc flash studies and PP can vary depending on the jurisdiction and the industry. However, NFPA 70E is widely recognized as the industry standard for electrical safety in the workplace. NFPA 70E provides detailed guidance on arc flash hazard assessment, PP selection, and safe work practices. OSHA also has regulations regarding electrical safety, which employers must comply with. In addition to NFPA 70E and OSHA regulations, there may be other applicable standards or regulations at the state or local level. It is important to be aware of all applicable requirements and to ensure that the arc flash study and safety program comply with these requirements.